Okay, this is the second part of the 8.6 notes. All right, so solving, we have logarithms involved. All right, I'll show you up here. If you had a log base 5 of x minus 7 equals log base 5 of 12, then what happens is this log base 5 and this log base 5 just really cancel each other out. And you just take the x minus 7 and set it equal to the 12 and then solve that. All right. So these are the easy ones. We have log 7 of 4x minus 3 equals log 7 of x plus 6. So again, the log 7 and the log 7 cancel each other out because there's one on each side. And it just leaves us with 4x minus 3 equals x plus 6. All right, and then we just have to solve that. So I'm going to subtract x from both sides and get 3x minus 3 equals 6. And then add 3, get 3x equals 9, and then divide by 3, and we get x equals 3. All right? And then the second one, B, we have log base 4 of 2x plus 8 equals log base 4 of 6x minus 12. Again, this side has log 4, this side has log 4. They cancel each other out. So it just leaves us with 2x plus 8 equals 6x minus 12. And then we just have to solve this. Now here I would subtract the 2x, subtract the 2x, gives me 8 equals 4x minus 12. Add 12 to both sides and get 20 equals 4x and divide by 4. Divide by 4 and we get x equals 5. All right, so those are the easy ones when you have a log on both sides. And they cancel out like that. All right, now, more challenging problems are when we don't have a log on both sides. All right, when we just have the log, like this one, a log base 2 on one side, but we don't have it on the other side. Now, in order to get rid of this log, what you have to do is you have to turn this whole thing into an exponent of whatever this base is. All right? So what we have to do is we have to make this whole thing into an exponent. So we're of this base. All right? So what we're going to do is, it's called exponentiating it. All right? We put this up in the exponent. So we would draw a big 2. Again, whatever this base is, that's the base you use here. So a big 2 there, and then a big 2 here. And we'd have to, because whatever we do to one side, we have to do the other side. So now we got 2 to the log base 2 of 3x plus 1 equals 2 to the 4th. Now what happens is these cancel out. So it leaves us with 3x plus 1 equals 2 to the 4th, and 2 to the 4th power is 16. And then we just solve this. Subtract 1, 3x equals 15, divide by 3, and we get x equals 5. All right, so let's see that once again. All right, once again, it looks like this. We have log base 7 of 3x minus 2 equals 2. All right, so we only have a log on one side. So again, to get rid of this, we have to make it a base of whatever this base is, and this base is 7. So we change that to an exponent. So we make a big 7 here, and then a big 7 here. All right, so these become the exponents of the 7s. All right, now what happens is this cancels this out. So we're left with 3x minus 2 equals 7 to the 2nd power, which is 49. And then we just have to finish this. So we add 2, we get 3x equals 51. We divide by 3, and we get x equals 17. All right? And again, that's called exponentiating. And that does it for the notes. All right? So you got these 4 tries I want you to do. And then you have another worksheet that is the 8.6. I don't know if it's labeled as homework or classwork, but you're going to do that also today.